So we have two concepts are pending. That is a problems on 2-watt meter method. Now I can explain how to solve the problems when they're given in the 2-watt meter method. Right, I'm going to share the PPT. Right. Is it visible? PPT.
Yes, sir.
Okay, right. Coming to the problems on 2-watt meter method, let us take a small problem first. What is the problem statement? We have to read out first one. The 2-watt meter method produces a wattmeter readings. That is, there are 2 wattmeters which are used to measure the power. That is, a wattmeter 1 reading is 1560 watts, and wattmeter 2 reading is 2100 watts, or 2.1 kilowatts, or 1.56 kilowatts, whatever. So when connected to delta connected load, so here both the wattmeters are connected for delta connection. So just to please remember that one. So here the 2-watt meter method is applicable either star connected network or delta connected network. It may be balanced or it may be unbalanced. So don't worry about it. So the analysis carried out for star connection is same as delta connection. There is no doubt. So that here the load is delta connected load. And if the line voltage is 220 volts, because in a delta connected network, the line and phase voltages are same. So what are the requirements? That is a requirement. What are the parameters we have to calculate means the per phase average power. That is what is the average power consumed by the load? Per phase reactive power. So for the same phase, what is the reactive power consumption? The power factor and the per phase impedance. So all these parameters we need to calculate, right? So coming to first, we need to draw the diagram. There you can understand. So that it is a delta connected system. Remember everyone, if any problem is asking regarding a problematic subject, better to draw the circuit always, so that it gives maximum idea, and also we can complete the problem in a systematic manner. That's why. So it is a delta connected network. So I'm going to draw delta connected network over here. So this is a load we have, and there is a one more load, and this is a one more load. So let the phases we are assuming, let it is R, Y, B. So here he did not mention whether it is balanced or unbalanced load. Generally, it is a delta connected load, so we don't bother about it. So there are 2 wattmeters which are connected. So let us take, if I connect the first wattmeter is always connected in series with the load, and the pressure coil is always connected across this load. This is 1 wattmeter, and other wattmeter I am going to connect for Y. So this is a current coil in series with the load. The potential coil is always connected in parallel with the load. Let it is P1. The second wattmeter is P2. If it is delta connection, this connection, that's a wattmeter connection is like this. Okay. Now the line voltage is 220 volts. So obviously the line voltage is 220 volts, but are displaced at 120 degrees. Here the phase shift is not required, so that you can take directly 220 volts. But we don't know the value of Z. This is what we are going to find. What is an impedance per phase means? I think this is a balanced load. So he is asking about per phase impedance. So we don't know the value of Z. That is impedance of the given circuit. That is what we are going to find. So within a given data, that is based on the given data, we can find the remaining parameters. So what is the total real or average power consumed by the load? Generally, we are using two wattmeters, P1 and P2. But the total reading should be always sum of both the readings. That is P1 plus P2. So 1560 plus 2100 gives 3.66 kilowatts or 3660 watts. That you can write like this. So that's the total power, input power or total power consumed by the system. Then what is the per phase power? Because he is asking about per phase power. He is asking about per phase power. What is the total power consumption? 3660 watts or 3.66 kilowatts. Per phase power we required. So how many phases are there? It is a three-phase system. Obviously, there are three phases. Now the total power is 3.66 kV. Then what is the per phase power? That is nothing but total power divided by 3. So therefore, the per phase power is always equal to whatever the power absorbed by the load divided by 3. That means 1 by 3 times of PT. It gives 3660 divided by 3. So that 31, 312. So 1200 and actually this is 1260, not a 1220, I think.
1220 and or 20 sir.
Wait. This is 1560 plus 2100. How much? Is it correct?
Yes, sir.
Correct, sir.
Correct, sir.
1560. Okay, 1560. And this is 3660. Sorry, 2100. Okay, that is correct. Then by 3.
Correct only, sir. 1220.
Right. Sorry. I'm thinking about first digit only. So this is 1220 watts, right? So the per phase power is always 1220 watts. That is, divide the total power divided by 3. There you can get per phase power. That means the per phase power, that is the impedance or the load absorbed by the per phase power is 1220 watts. Then what is the total reactive power? So remember, while calculating per phase power, that means average power or reactive power, whatever, first you need to calculate the total power. Then you can take by 3, then only you can get per phase power. So therefore, what is the total reactive power? So the total reactive power is always equal to Qt is equal to root 3 times of a difference of both the wattmeters. You have to consider this one, not only P1 minus P2 or P2 minus P1. That is always, it depends upon the connection of the wattmeters. So that we have to take only difference. So what is the difference of both the wattmeters? So here P2 reading is more compared to P1. Therefore, I can take this is more dominant value compared to the P1. So therefore, I can take P2 minus P1. Then root 3 into what is this value? That means 2100 and minus 5060 gives, we have 935.3 volt ampere reactive. So the units for the reactive power is 935.3 volt ampere reactive. This is a total reactive power consumption for 3 phases. Now what is the requirement? Here the per phase reactive power he is asking. Then what can I do? What can we do now? This is the total reactive power consumed by the load. What is the per phase reactive power? How can you get? Are you there?
Yes, sir.
Then how can you get it? Same. This is the total power. Per phase power you can take by 3. If it is a total reactive power, then what is the per phase power? Again we can take by 3. So therefore, the total power is nothing but Qt. Now the per phase reactive power is nothing but Qp is equal to Qt by 3. and it gives 311.77 volt ampere reactive. What is the next third one? Power factor, that is nothing but C. So what is the power factor angle first? That is nothing but pi. Afterwards, you can take cosine of that angle is nothing but power factor. So cosine of that angle is nothing but power factor. So therefore, pi is equal to tan inverse of Qt by Pt. Yesterday, we already told that the angle pi or the theta is equal to, we have some expression, right? That is a tan inverse of root 3 times of tan inverse of root 3 times of the difference of both the wattmeters P1 minus P2 divided by total power consumed by the load, that is P1 plus P2. This is an expression we have obtained in the previous class. Then what is the angle? Therefore, tan inverse of, what is the numerator value? It should be Q. So therefore, I can take this is total reactive power divided by, the denominator is a total active power. Therefore, I can take this is PT. So directly you can write it. So the angle is Q is equal to, pi is equal to, or theta is equal to tan inverse of Qt by Pt. We already know the value of Qt and Pt values. Now substitute over here. Then it gives 14.33 degrees. This is an angle only. Then what is the power factor? If you know the angle, its power factor is always equal to cos pi or cos theta. Therefore, cos of this value for 14.33 is nothing but 0.9689. It should be leading. When it is should be leading in the sense, the Qt is always positive and it is for P2 is greater than P1. So how to identify whether it is lagging or leading, that I can explain in the next class. But you have to remember always the power factor is to be either lagging or leading, that we can explain. Coming to the next, per phase impedance. So what is the per phase impedance we are going to take? Here the power factor is leading in the sense, the power factor is more than, that is a load based on connection of the load, that's a reactive power. So make a reactive power base cheskone, it should be leading or lagging anedi chupistundi. So if we get the positive reactive power, we can take this is a leading power factor. If it is negative, then we can go for lagging power factor. So the phase impedance, per phase impedance we are going to calculate. It should be always magnitude and phase angle. That's a polar form. So we already know that the angle is already, that is we already calculated the angle, that is 14.33 in the previous here. Coming to per phase impedance equation is Z is equal to V by P. So if we go to the diagram, this is what we are going to find. So what is the voltage of this impedance is Vp, that's the phase voltage. What is current through this one? I phase. So if you know the value of V phase and I phase, it is easy to calculate impedance value. Per phase impedance is always equal to V phase by I phase. Again, we recall for a delta connected load, V phase is equal to VL is equal to 220 volts, because in delta connected network, the line voltage and phase voltage are same. There is no doubt. So V phase and VL is equal to 220 volts. Then what is the per phase power we have in the expression? What is the per phase power we are having? 220 volts, 1220 watts. So that per phase value is, this value should be 1220 is equal to, we already know that V phase is nothing but 220 volts into I phase, we don't know, into what is cos theta? That means 0.9 something, that means 9689. That is already calculated. Then what is the required value here? IP. Therefore, IP is equal to, how can you write 1220 divided by 220 multiplied with 0.9689. So 220 into 0.9689, it gives what is the current through the load, that is per phase of the load. That's the phase current. So the phase current is 5.723 amperes. This is the phase current, right? Now what is the per phase impedance? So if you know the value of V phase and I phase, then its per phase impedance is to be 38.44 ohms. That is 220 divided by this phase current 5.723. I can get 38.44 ohms. This is only magnitude. How to calculate the phase angle? Because the phase impedance, per phase impedance of any three-phase system is always in terms of either rectangular form or a polar form. If you want to represent it is in polar form, definitely we require magnitude as well as phase angle. Therefore, Zp is equal to, we have only magnitude 38.44 ohms and its phase angle is always equal to 14.33 degrees. Therefore, finally, the per phase impedance of three-phase system is to be 38.44 at an angle of 14.33 degrees ohms. So this is a way how to calculate per phase impedance, phase current or line currents, and all other components for the given problem. I hope you understand. Okay, so please note down the problem and also solve the number of problems which are related to 2-watt meter method, because very important for the competitive exams or end examination. Surely in the end examination they can ask a question from 2-watt meter method, either derivation part, calculation of power factor, or calculation of total power or reactive power, or the problems, whatever. So this is one of the important concept. So coming to the next problem, that's the first problem. Just now I explained only second one. I'm going to take first one. The next problem is 2-watt meter method was used to determine the input power to a three-phase motor. We don't know the motor connection or everything, but this is used to give the input power to a three-phase motor. Now the readings of 2-watt meters are the 5.2 kilowatts and minus 1.7 kilowatts. That means one of the watt meter reading is 5.2 kilowatts and the other watt meter reading is minus 1.7 kilowatts. And the line voltage given, that is 415 volts. Then calculate what are the parameters we need to calculate. The total power. What is the total power absorbed or input to the motor? That's the total power given to the motor. Then what is the power factor? So what is the power factor of the load? Then what is the line current? So we need to calculate power factor, line current. So what is the total power we need to calculate? Total power is always equal to sum of both the wattmeter readings, that is P1 plus P2. This is mandatory. Now what is the power factor of the load? So power factor is always equal to cos pi. Then how to obtain the pi value? So pi value is equal to, again we have some formula, that is tan inverse of, again root 3 times of the difference of both the wattmeter reading, that is P1 minus P2 divided by P1 plus P2. So this is the formula to find the phase angle. Once if we calculate the phase angle, it is easy to calculate power factor. Then what is the line current? So generally the total power absorbed by the load, if you know, root 3 into VL IL into cos pi, root 3 VL IL into cos pi. So total power we can calculate from the first to this one. And VL, we already know that is given in the data. Cos pi, we know that from the second one. So it is easy to calculate the load current or the line current IL. Look at this one, first one. What is the total power? So the total power P is equal to P1 plus P2. And it is already given. P1 reading is 5.2 kilowatts. And the next reading of the given system is minus 1.7 kilowatts. Then what is the total power? So the total power of the load is equal to 3.5 kilowatts. That is add both the wattmeter readings. There you can get the total power. That means one wattmeter reading shows positive and other wattmeter reading shows negative. Yesterday we had a small introduction about this one. When the 2 wattmeter reading shown, one is positive, other is negative, that is at the power factor or at the phase angle of watt. Can anybody? Why one wattmeter reading shows positive, other wattmeter reading shows negative means What is the power factor? Right, in between 0 to 0.5 only. Like that you have to say, right? So the power factor is always between 0 to 0.5. ఆ మధ్యలో ఉంటేనే మనకు నెగిటివ్ వాల్యూ చూపిస్తుంది ఒక వాట్ మీటర్ కి. డోంట్ సే డైరెక్ట్లీ 0 or డైరెక్ట్లీ 0.5. In between 0 and 0.5, then the power factor, if the power factor is in between 0 to 0.5, then the wattmeter reading should be one is positive, other is negative, right? So therefore, then tan pi we need to calculate root 3 into P1 by P2, sorry, P1 minus P2 by P1 plus P2, root 3 times of 5.2 minus, where next wattmeter reading is negative already. So minus of minus 1.7 divided by 5.2 plus minus 1.7, which gives 3.41 value. Then what is the power factor? I mean, pi. Pi is equal to tan inverse of 3.41 and it gives 73.39 degrees. Then what is its power factor? So its power factor is nothing but cos pi. Then cos of 73.39 degrees is nothing but, what is the power factor of the load? It should be 0.281. So that is the power factor is always in between 0 to 0. That is cos pi less than 0.5. That means if one wattmeter reading is positive, other wattmeter reading is negative, means the power factor is always in between 0 and 0.5. If the power factor is greater than 0.5, automatically both the wattmeter readings are positive. If the power factor is unity, both the wattmeter readings should be same. Then what is the next one? So what is the third one? Load current, I mean line current. We already know that this is a relationship I explained here. P is equal to root 3 times of VL IL into cos pi. Therefore, this total power consumption, that is 3.5 kilowatts, is nothing but 3,500 watts. So either you can represent this value either kilowatts or watts. So both are same. So 3,500 is equal to root 3. Now the line voltage is given VL IL into, and this is a power factor, right? That is nothing but cos pi. Then what is the line current? IL is equal to 17.3 amperes. See how it is very easy. For end examination purpose, they can ask 5 to 7 marks for this question. But at the competitive level examination, they can go for only 1 mark question, like in GATE examination. So students, please refer the textbook, either Alexander textbook or Chakrabarti or CL Vadva or any other textbook which is related to 2-watt meter method. Then solve all the problems, including there are number of problems are available in the textbook. Please read textbook and find the number of problems. If you have any doubt in that problem, you just write the problem on a paper and WhatsApp to me. Then I can solve the paper and I can post in the group. If you have any doubt, please contact me. So 2 problems are over. I think this is the end of unit number 2, and we will start unit number 3 in the upcoming class. Thank you. Any doubt regarding this, please? Anybody having doubt?
No, sir.
So if anybody having doubt, please raise your hand or just directly ask me, then I'm ready to explain. Okay, can you write the problem now? Yes, write the problem. I can share the problem. There you can understand. So I'm going to take Chakrabarti, Sir Alexander. రైట్. డాక్యుమెంట్ మీకు కనిపిస్తుందా?
Yes, sir.
Okay, right. I'll go with the three-phase circuits. I can give only one problem. Please note down the problem and let me the answer for this problem on tomorrow. 477 page number. So power measurement. Where is power measurement? 494. Right. Now I can give the problem on 2-watt meter method. You please note down the problem and find the answer for tomorrow class.
Okay, sir.
I think this is now given. Already clear this is. I think this is completed now. Right. Note down the problem. Let the line voltage VL is equal to 208 volts and the wattmeter readings of the balanced system as shown in figure. That figure I can show. You just note down the question first. Let the line voltage VL is equal to 208 volts. And the wattmeter readings of the balanced system is shown in figure will be P1 is equal to 560 watts. That is with negative polarity. The next wattmeter reading is 800 watts. Determine the total average power, that is nothing but P. So that you have to remember this one. You have to calculate the average power is nothing but P. Total average power is P. Next, total reactive power. So that you have to calculate total average power is P. This is P. And the total reactive power is nothing but QT or Q. Then what is the power factor? That is nothing but cos pi. So the power factor is nothing but cos pi. You have to find. Then the phase impedance, that is a far phase impedance ZP. So remember the far phase impedance is always magnitude and phase angle. Right. Finally, he has asked one question. He is asking, is the impedance is inductive or capacitive? So this is also we need to calculate. So answer is given. It is an inductive means the magnitude and phase angle. The phase angle is always positive. So note down these values. There you can understand. So find the values. So now I'm going to show the diagram. That is it's a balanced system shown in figure 12.35. So where is 12.35 diagram? I'm going to show the diagram. I think this is 12.36. So 12.35, right. Note down this diagram. It is a star connected balanced system. Let the phases are A, B, C. So the first wattmeter is connected for phase A. Next wattmeter is connected for phase C. But both the pressure coil of 2 wattmeters are commonly connected to phase B. Look at this one. There you can understand. నిన్నే చెప్పాను మీరు ఏవైతే 2 వాట్మీటర్స్ కనెక్ట్ చేసుకుంటున్నారో వాటి యొక్క ప్రెషర్ కాయిల్స్ థర్డ్ ఫేజ్ కి కామన్ గా కనెక్ట్ చేసుకోవాలి. దట్ ఈస్ కామన్ ఇన్ కేస్ ఆఫ్ 2 వాట్మీటర్ మెథడ్. సో ఇక్కడ ఏ సి both are phases having same wattmeter current coils and their potential coils are commonly connected to phase B. So note down this diagram, find the values for the tomorrow's class. Okay. So many problems are there. You better you solve all the problems. Then only you can idea, at least. Note down this problem also. Delta connected load with an per phase impedance of 30 per phase impedance of 30 minus J40 ohms. The line voltage is VL is equal to 440 volts. It is a delta connected network. So it is a delta connected network. Like this, we have to connect the delta connected network. So what is the given data? Per phase impedance is 30 minus J40 ohms. So this impedance, and this impedance is to be 30 minus J40 ohms. The line voltage is 440 volts. So what is the line voltage here? It is to be 440 volts. Now predict the readings of two wattmeters W1, W2. Calculate the total power and reactive power, PT and QT. So what is the equation for PT and QT? So PT is nothing but adding of both the wattmeter readings. Now QT is nothing but √3 times of subtraction of both the wattmeter readings. So first you need to calculate the readings of the wattmeters. There we can get the values. So what is P1, what is P2? So I'll discuss in the next class. Thank you.
Sir,
Yeah,
offline classes have been taking place from next week. sir.
right. Today we had meeting with the director, sir. So he is going to, calling you to the college by the next week, based on situation.
From
Now
24th
still the cases are increasing.